I welcome you all for this lecture series on artificial intelligence and machine learning. In this lecture, we'll see one example problem for iterative deepening depth first search. This iterative deepening depth first search, shortly we are calling it as IDDFS. We'll see the algorithm. So this is one example graph for this IDDFS, that is iterative deepening depth first search. In this case, we begin with the node A. We begin with the node A. Node A is the parent node. This is the starting point. This node A, we are calling it as the starting point, and here this is the goal node. And as the starting point of the tree is the A, the goal is to find the goal node G, which is located at the depth 2 in the tree. This is the depth 0 and this line is the depth 1, and the goal node is situated in the depth level 2 in the tree. The idea behind iterative deepening depth first search, that is IDDFS, is to perform depth limited. We are going to perform depth limited search DLS, starting from the depth 0 and increasing the depth limit after each iteration until the goal is found out. So in the DLS, if the depth level is 1, it has to, the algorithm will stop over here. But in this case, IDDFS, the algorithm will move until we get the goal node. Each step by step, it will go the depth 0, depth 1, and then it will go to finally depth 2. So this is the main basic idea of this depth IDDFS. And here, starting from the depth 0 and increasing the depth limit after each iteration until the goal is found. The first iteration, this is the first iteration, here the starting node is A and goal node we are fixing it as G, and the how many depths are there? This is depth 0, depth 1, and here this is the depth level is 2. First iteration 1. In the iteration 1, the depth limit is 0. Here, this is the first iteration. In the first iteration, the depth limit is set to 0, meaning the search will only explore the root node. What is the root node? The root node is, so in the iteration 0, that is the first iteration, the search will only explore the root node A. At this level, the only node that can be explored is A itself, only A itself. We check if A is the goal node, but it's not. Since there are no further nodes to explore to depth 0, the search in the first iteration, the search halts over here. As the goal was not found, we increase the depth limit to 1. From 0 to 1, we are moving, increasing the depth limit to 1 and proceed to the next iteration. So in the iteration 2, what will happen is the depth limit is 1. In the second iteration, we increase the depth limit to 1. Now the search explores the root node A, and again that is again, and it immediately, that is the immediate childrens are B, C, and D at all at the depth level 1. The search checks each of these nodes to see if any of them match the goal node G. B, C, D are not the goal node. However, none of these nodes are the goal since there are no further nodes to explore at depth 1. The search stops here. As the goal is still not found, we again what will do? Increase the depth level. Here 1, 2, we are moving into depth level 2. That is depth limit to 2 and begin the next iteration. So on iteration 3, the depth limit is 2. In the third iteration, the depth limit is set to 2, meaning the search will explore the node up to from here to here and then will move on to the depth 2. Starting from node A, the search explores its immediate children B, C, and D at depth level 1 and then moves on to explore their children at depth 2. Specifically, node B has two children. What are they? E and F, which are explored at depth level 2. Node C has only one child. What is that child? This is the G, the one child G, which is this node is the goal node located at the depth level 2. Once the goal node G is found at depth 2, the search stops and successfully concludes. Since the goal has been located, there is no need to increase the depth limit. So even though if you have, that is, suppose if you have 3 depth levels, goal is over here, we have to stop over in this. There's no need to increase the depth limit further and the search is complete. Here, this search is, in this case, the search is complete. So in this example, we can explain it by using the table also. So this, you can see the graph A to B, B to, that is A to C and A to D, and B to E and F, C to G and D to H. This we can explain it in terms of table also. We can explore it in the table. So in the first iteration, the depth limit is 0. What is the initial node? Starting node is A. Goal is found? No. What is the action for this? Explore node is A and goal is not found. Hence, we have to increase the depth from 0 to 1. And in the second iteration, depth limit is 1. And the nodes explored are from A to B, C, D. And the goal is found? No. And explored nodes are A, B, C, and D. Goal is not found. And we have to increase the depth limit to 2. And the third iteration, the depth limit is 2 and the nodes explored are A, B, C, D, E, F, G, H. And whether we have found out the goal node? Yes, we found out. And the explored nodes are A, B, C, D, E, F, and G. The goal G is found out at depth 2. So coming into the conclusion, the iterative deepening depth first search, IDDFS, no? So it increases the depth limit one by one and running new depth limited search at each level, right? And explores each node at the current depth limit and move to the next level once the search completes. And where we are finding out the goal node at depth 2, we are finding out the goal node G under the node C and the search ends successfully. So coming into the conclusion, the iterative deepening depth first search successfully finds the goal by exploring nodes layer by layer, starting from depth 0 to layer by layer we are moving, depth 0 to and gradually increasing the depth limit. This method ensures the algorithm is complete. It will given goal, we are saying it will find the goal if it exists, and it nodes at once, like breadth first search BFS. By increasing the depth limit incrementally, IDDFS combines the benefits of DFS, that is depth first search, and breadth first search, making it both practical and effective for many search problems. So this algorithm, everyone able to understand. And coming into the final slide, the iterative deepening depth first search combines the benefits of what? BFS, breadth first search, and depth first search, offering a complete and optimal solution. By iteratively increasing the depth limit, IDDFS balances exploration and exploration and exploitation. So this is one advantage of using this IDDFS and making it suitable for applications where both completeness and optimality are crucial. Its time complexity, we can say that order of b to the power d, and the space complexity is order of d. Make it a valuable algorithm for solving complex problems in artificial intelligence, robotics, and computer science. Hope everyone understood this lecture. The remaining things we'll discuss in the next lecture. Thank you.